Kia ora, Year 12. This is a really old excellence question from the 2012 Integration Standard. Now, the achievement standard has changed since then, so some of these old questions that I'm doing are a little bit different, but this one I think would still fit really well in a Level 3 integration paper. So pause the video and have a look at it, and then I'll go really slowly through it. Okay, so we've got a cylindrical tank that I've drawn over here, and it's got a hole in the bottom of it, and the water is leaking out. This is the rate of change of volume with respect to time. And this is the formula here that gives us the volume of water in the tank. So if you think about it, this is quite a straightforward problem in some ways because the surface area of the water is not going to be changing because it's a cylinder. It's not like where we've got a problem with a cone with a leak in it. Okay, so it's not as bad. What we're given here is a link between volume and time, and the first part of the question asks us to form a dE for the rate at which the height is changing. So we need to find dH by dt. Right, there are lots of ways to think about this, but you can see that there is a clear link between height and volume. So we're going to set up a chain rule relationship. So dH by dt can be expressed as this. Right, so as time passes, the volume's changing, and as the volume changes, the height is dropping. That's one way to think about it. Mechanically, that makes it a really easy problem. We're given dV by dt, it's up here, and we can find dH by dV. So dV by dH is just equal to A. So dH by dV is 1 over A. So what does that give me? Well, I get this. dH by dt is equal to 1 over A times dV by dt. So it's 1 over A times negative K root H. And I can write that more elegantly as negative K over A root H. So that gives me dH by dt. So that's the first part of the problem done. Okay, and that was an achieved question. I think it's quite hard for an achieved question if you don't spot what's going on. Now the next part is a pretty traditional figure out how long it takes until something happens. We're given the cross-sectional area of the tank is 0.5 meters squared. So A is equal to 0.5. And we're told that when T equals 0, H is 144. When T is 160, H is equal to 100. And we have to find out how long it will take for the tank to empty. So there are two ways to think about that. You can work with looking for the volume to be 0, or you can just work with the height being 0. So we're going to solve for when is H equals 0, because if you look at, wrong pen, this equation, we've got that dE and we're ready to go. You can see that it's a simple case of separating the variables. So when we do that, this is what we're going to end up with. 1 over root H dH is equal to negative K over A dt. And we're going to integrate both sides. So this is H to the negative 1/2 dH. And on this side, I'm going to get negative K over A T plus C. Right, as we often have, we've got two constants that we have to find. The first one is going to come from substituting in T equals 0 and H equals 144. But before I do that, I have to integrate the left-hand side. Now that's going to give me H to the 1/2 times 2. So we get 2 root H equals this. And now I'm ready to substitute. So 2 times root 144 is equal to C. C equals 24. That's the first bit done. The next point that we're going to substitute is T equals 160, H equals 100. So 2 root H. Well, we know A now as well, don't we? So A was 0.5 and T is 160 and C is 24. So 2 times 10 for the square root of 100 is negative 320k plus 24. 20 minus 24 equals negative 320k. K is equal to negative 4 over negative 320, which is 1/80th, so 0.0125. Finally, we can chuck that all back into our equation. So we've got 2 root h is equal to negative 2 times 0.0125 t plus 24. This is coming from the 1 over a. All I have to do is to solve for when h is 0. So I'm not going to explicitly get an expression for h because I'm working under time pressure. So h equals 0. We want to have 0 equals negative 0.025t plus 24. So t is 24 over 0.025. So 24 times 40, 960. I think we were talking about hours. I better check that. Okay, so that's that question done. So I think in some ways, once you've seen the link between the two equations that I'll go back up to, so once you've seen the link between equations 1 and 2, this problem falls apart very, very easily. But this is the bit that needs a little bit of thought. If in doubt in a differential equations problem, though, the chain rule is going to help you, just as it does with all of our related rates problems. Okay, I'll be back with more tricky questions later on, either today or tomorrow. Thanks for watching.